This is section 3.3, day 2. We have the product rule. Given two differentiable functions u and v, if we take the derivative of their products, to take the derivative of the products, you take the first times the derivative of the second plus the second times derivative of the first. So we have an example here. Two kind of basic functions, one a quadratic and another a third power cubic. So we're going to take the derivative of this product using the product rule. So y prime is equal to, let's see, y prime first times the derivative of the second, which is 3x squared, plus the second, x to the third plus 1, times the derivative of the first. So we have times 2x. So the derivative is, let's see, 3x to the fourth plus 9x squared plus 2x to the fourth plus 2x. So we have 5x to the fourth plus 9x squared and then plus the 2x. The product rule, derivative of a product. First times derivative of the second plus the second times derivative of the first. Now if we're just given values, the function u at 4 is equal to 4, v of 4 is 1, and so on. U prime of 4 is negative 3, and v prime of 4 is 2. We're going to let y equal u times v, the two functions multiplied. So the derivative is the first, which is u of 4, times the derivative of the second, times v prime of 4, plus second, so v of 4, times derivative of the first, which is u of 4. And now we just fill in the values. So we need u of 4, which is 4. I need the derivative of v, which is 2. We're going to add that to v of 4, which is 1, and then times, first times derivative of second, plus second times derivative of the first. There we go. There's the product rule. And then we have u prime of 4, which is negative 3. So we have 8 minus 3, and that is 5. The value, the derivative of y at 4 of the product of these two functions is the value of 5. The quotient rule, if we want to take the derivative of two functions divided, it is top times derivative of the bottom minus the bottom times derivative of the top, and then it's all over the bottom squared. And we say that's low d high minus high d low all over low squared. So it's bottom times the derivative of the top minus top times derivative of the bottom over the bottom squared. Here's an example. Find the derivative of f given f of x equals x squared plus 3 over x squared minus 2. So we're thinking this is a function on top and this is a function on the bottom. So f prime of x in this case is bottom times derivative of the top, which is 2x minus top times the derivative of the bottom, which is also 2x, all over the bottom squared. X squared minus 2 squared. So we can clean this up a little bit. We can have 2x to the third minus 4x minus 2x to the third minus 6x all over bottom squared. X squared minus 2 squared. And that's equal to, let's see, the 2x to the thirds will cancel out. And we have negative 10x over x squared minus 2 squared. And there's the derivative. The quotient rule is not needed for the following. We don't really need the quotient rule for this one. We can make this into, common denominators. We can have x to the third over x. That's x squared. We can have 5x over x plus 5x over x. The x's cancel and we have plus 5. And then minus 7 over x, which is equal to x squared plus 5x minus 7x to the negative first power. And then we can just use the power rule. So we have 2x plus 5 plus 7x to the negative 2, because remember you're going to minus 1 from this power. So finally we have 2x plus 5 plus 7 over x squared.